Hi, good morning. Today's lesson is on 6.5, the graphs of the reciprocal trig functions. I just want to quickly remind everyone the reciprocal of the trig functions for each one of them. The cosecant is the reciprocal of sine, and the secant is the reciprocal of cosine, and the cotangent is the reciprocal of the tangent. Okay? And the best way to remember for each of the reciprocal is that I will look at the first letter, okay, and you know that the cosecant start with the C is the reciprocal of the sine, which is not the same letter, okay, because a lot of you will easily mistaken that the cosecant will be the reciprocal of the cosine. So I just want to remind you with the special method that all you have to remember is the reciprocal of each of the trig functions, they will have a different letter, okay? And then the cotangents will be easier because the cotangents basically is the reciprocal of the tangent. So it's not that easy to get this mixed up. But knowing that the reciprocal of the cotangent, which is the same as when you taking the cos over the cosine, okay? So that is something that that you need to keep in mind. And if you recall the special properties of any of the reciprocal functions that we did earlier, and I just want to quickly remind each of you the 5 main features of the or the 5 main special properties of the reciprocal functions for any kind of a function, and that same special properties also apply to the trigonometry functions, okay? So what are they? Well, it's that it has a vertical asymptote at each 0 of its original functions, okay? It has the same positive or negative intervals of its original functions. And number 3 is it has the opposite interval of increase or decrease of its original functions. And both the reciprocal and its original function intercept each other at the point where the y-coordinate is 1 or -1. Okay? So the point of intersections between the two. And finally, it has the opposite. It has the opposite local max, okay? And or the minimum, okay? Local max and min, they're the opposite of its original. Okay? So let's quickly look at, let me show you. So how does that apply to the trig functions? So let's say if we're going to have the sine functions here, okay? So the parent functions, the base function of the sine function is start with the equation of axis, which is the middle line, which is the y equal to 0. Okay, start there. First quarter at 90 degrees up to the maximum. Second quarter at pi, you're back onto the middle line. And the third quarter at 3 pi/2, it goes down to the minimum, -1. And the last quarter back to the 2 pi on the equation of axis. So if we slowly connect all these key points, this is my sine graph, okay? So for the sine graph, and from the graph, I'll check each of these special properties here. And I think the very first thing that I'll do is that at each of the 0, I'll get a vertical asymptote. So the first 0, it happens at the starting point. So I'm going to have my first VA right here, x equal to 0. Okay? And my second one, it will be where the pi is. So I'm going to draw myself this broken line. So I have another VA here at x equal to pi. And lastly, I have a 0 at 2 pi. So I'm going to have another VA at x equal to 2 pi. So all of this, you need to label it clearly on the graph, okay? So the vertical asymptotes where the original has a 0. And secondly, it has the same positive or negative interval of its original. So obviously for from 0 to pi, where the original function is above the x-axis, so my reciprocal will also be above. But between the pi and 2 pi, my original function is below the x-axis, then obviously the reciprocal functions will also be below the x-axis, okay? I'm going to show you that after I've gone through all of those key points here, okay, the key feature. So it also has the opposite interval of increase and decrease. So for the first, from the 0 to the pi over 2, it has an interval of increase. So that means I'm going to have an interval of decrease, okay? So I'm going to have an interval decrease from the 0, okay? And I'm going to intercept the original at the point where the y is equal to 1, okay? And because I have a vertical asymptote here, so that means my curve here is going to be approaching to the vertical asymptotes, okay? And having an interval of decrease, intercept at its original at that point, at 1, where the y coordinate is equal to 1, okay? And the second part, from 90 to 180, I have an interval of decrease, so that means I need to have the opposite, okay? So I need to go back up to have an interval of increase and keep approaching to the vertical asymptotes. So the first part of the reciprocal is going to be look like this, okay? So the red line will represent the reciprocal functions, okay? So they're both positive above the x-axis, and this part is interval increase, so I have a decrease. So this part I have an interval of decrease, now I have an interval of increase, okay? And they both intercept at the point where the y coordinate has the 1, okay? And it also has the opposite local max and min. So the original function has a local max here, but now on the reciprocal becomes a local min, okay? So once I start graphing the reciprocal, you will get to see each of this point is actually matching. Now for the other half of the original functions, so because it's below the x-axis, so my reciprocal is also below, so it won't be up here. So this is interval of decrease from pi to 3 pi over 2. So I'm supposed to have an interval of increase. So because this is also a -1 where they both should intercept, so my reciprocal for this part is going to be like this. So I'm getting interval of increase. This is an interval of decrease. This is a local min. Now I'm getting a local max, okay? For the other half, interval of increase, so that means I'm going to have an interval of decrease approaching to the vertical asymptote, okay? So this red one is going to be my y equal to cosecant theta, okay? The blue one is going to be the sine theta, but the red one is going to be the y equal to cosecant theta. So this is the reciprocal graph for the sine function. So it's pretty straightforward. And I'm only did one cycle over here. But if you want to continue with another cycle, that means your reciprocal function will have multiple parts, but similar to the one that I have here for the first cycle. Okay? Now let's move on to do the reciprocal for the sine. So I'm going to give myself this cos functions, cos theta functions here. And we all know that the base function for the cosine, you always start at the max. So my starting point is at 0, 1. For the first quarter, it going down to the middle line, which is the equation of axis, y equal to 0. And second part of it, the second quarter, will be the minimum. And the third quarter, I'm back to the middle line. And the last quarter, I'm back to the maximum. Okay? So when you slowly connect all of this with a smooth curve, okay? So this will be your cosine functions in blue. Now, if I'm going to matching all of those special properties for the reciprocal, first I'm going to identify where the 0 of this function is. So I'm going to put in my red broken line along x equal to pi over 2, because this is where the VA is, the first VA. And the second VA, the vertical asymptote, is happening at the 3 pi over 2. So x is equal to 3 pi over 2. Okay? And that's where my second VA is. And so unlike the sine functions, I only have 2, 0 here for this cycle. Okay? And then where the y-coordinate of my original has the 1 or the -1 is where the 2 intercept. So that means my reciprocal will intercept each other at here and also at here as well. So from 0 to pi over 2, the original cosine function is above the x-axis, so that means my reciprocals also is above. But this one has an interval of decrease, so I'm supposed to have an interval increase, but intercept at this point here. So that means this interval of increase for this part. Okay? Now, between pi over 2 and pi, I have the negative interval, which is the below the x-axis. So that means my reciprocal is also below the x-axis. So nothing should be up here. But also because it intercepts at the -1, having an interval of decrease, so I'm supposed to have an interval of increase from here. Okay, intercept at this point. But the other part is also approaching to the vertical asymptote, so you need to show the arrow for this part for approaching to the vertical asymptotes. Okay, and because this is a local min, so now it becomes a local max by continue with the reciprocal, where this part between pi and 3 pi over 2 is where the interval of increase, so I'm supposed to have the opposite, so interval of decrease approaching to the vertical asymptote as well. Okay, so this is a 3 pi over 12 over here. Okay, so they are below the x-axis. So interval of decrease, so interval of increase. Interval of increase, I have an interval of decrease. Okay, intercept each other at that point. And for the last part, again here, because I have the intersections point at the original at the y-coordinates equal to 1 over here, so that means this part is in the positive interval, so it will not be down here for my reciprocal. And I will have, this is an interval increase, so I will have interval of decrease, intercept at this point, but I will have an arrow there. Okay, so that is the reciprocal functions of the y equal to secant theta. Okay, so this 3 parts here will be the y equal to secant theta, which is the reciprocal function of the cos theta. All right?